understand what is short circuit. Yes. And now I will just show you a part called dynamic declaration. What is dynamic declaration? Just I'll show you what is dynamic declaration. In the meantime, just I'll take these all these things. So I'll just show you what is dynamic declaration. And the dynamic declaration, for example, I'm just declaring a comma b comma c, for example. And let me assign a with 2 and b with 5 and c with 10, let me assume. And now what I do is that I write a if condition. Just let me make a condition. I will just write if b is greater than a. If b is greater than a, then what I need to do is a is equal to b. So if the second number is greater than the first number, then change the first number into second number. So since 5 is greater than 2, I will 5 is greater than 2, I will change a also into 5. That is what the process. Okay, so but what I am going to do is I'm introducing a new variable. I'm declaring a new variable inside if condition. I'm not declaring it outside, I'm declaring inside the if condition. And if I declare it inside if condition, and what I'm doing is that I'm just taking this I'm just instead of assigning b to a, I'm assigning c to b. Actually, I'm assigning c to b, and after assigning b to c, and I will be printing the value of c, variable called c. And I do this printing statement both inside and outside the if condition also. I'll just print the c. So what you have done, you have taken three variables a, b, c, and sorry, it is not c because outside also you are having c, right? So what you do is take the new variables at d and just print d, and outside also just print d. So now what will happen? Just you can go and just execute and just check what is going to happen. So compilation is throwing an error that d is undeclared. What's the reason? D is undeclared because you are declaring the variable inside this if condition. So what will happen is once this if condition block is closed, then this memory block will be deallocated automatically. The memory that is allocated for the variable d will be automatically deallocated when it is seeing this close curly braces. So automatically outside the if block there might be no variable called d. This I will just show you a demo here by just doing this doing a debugging process here. So what I will do is I'll just convert this into a breakpoint, and I'll just convert this. So what I'll do is, since there is an error, I'll just take this printf statement out, and I'll just write outside. I'll just write printf percentage d comma. I'll just print the value of c just for the sake of demo. For the sake of demo, just I'll just print percentage d comma c. Fine. So now what I will do is, I'll start the debugging process, line by line execution process. From third line, I'll just start this debugging process. Yes, the debugging process is started. I think in the previous videos itself, I told you that the compilation starts from the main function whenever a main block is invoked. Whenever the main block is starting its execution, a corresponding activation area will be created in the stack memory. Stack memory means RAM memory. Okay, so after creating an activation area, what will happen? Whatever the variables which is required inside that block will be created inside this stack activation area only. So inside main activation area, if you see, by default it is taking ABC, but the garbage values are there. Don't see that is 040, it's a garbage value. Now what I will do, I will execute fifth line. If I execute fifth line, automatically the values becomes 2, 5, 10. But so far, if you see, in the main function, there is no variable called d is there, because till now you have not declared it, so it is not coming in the game. So now I'm checking for the if condition. If this if condition is true, I will enter. So I think this if condition is true, because b value is 5 and a value is 2. So this if condition is perfectly true, so it will enter inside. Once it is entering inside, now what happens is, there is a new variable called d, and it is having a it's having a garbage value. Don't think that this is the 5. Okay, so this d value is assigned with a random value. So now I will execute this d equal to b. So automatic 5 value 5 will be just allocated, 5 will be assigned to d, and now what I will do, I will just print the value of d. And once I come out the if, now if you see that variable d is not found, because once it enters into if, this variable is allocated memory with, and once it is coming out of this if it is seeing this close curly braces, automatically the memory allocated to this d is deallocated. So when you come out, you cannot print d. This is what we call it as local variable, actually the scope. But this is what is the background process that is happening inside the compiler. That is what I'm showing you, the inside part of the compiler. Okay, so this is called as the dynamic declaration part. Dynamic declaration: whenever you declare a variable inside a block, that variable will be deallocated when it is coming out of that particular block. Okay, so hope you understand about this dynamic declaration part also. Yes, so what we will do next is, we will see about switch case. Okay, we will see about switch case. That's the next thing that we will be doing. So the next concept we will be seeing is switch case, as I am telling now. So now what we will be doing is this. Let me take all these things off, and we will start. So now, what is the usage of switch case? Switch case will be used to write a menu driven program. So it is it is used to write a menu driven program. When you want a switch, whenever you want to write a menu driven program. We will see one example of what is a menu driven program is. For example, there are 7 days in a week, and what I'll tell you is that I'm going to take an integer variable called day, and using scanf I will receive an integer value from user for the and store it in the variable called day. And now what I will do is, if this day is equal to 1, if the user is entering day 1, then it is a Monday, it refers to Monday. And case 2, if it is equal to if it is 2, the number is 2, then it is referring to Tuesday. It is 3 Wednesday, 4 Thursday, Friday, Saturday, and Sunday. In this order I'm going to follow. So you can write also if statement, but this is like a menu driven program. If this is first case, you do this. Case 2, do this. Case 3, do this. So when it is like a menu driven, a classification is provided, then you can go with this switch statement, switch condition. So first of all, what I need to give us the protocol is that switch is the keyword and followed by a parenthesis. Inside this parenthesis, you have to pass the variable that is going to store either an integer or a character. Apart from that, you cannot use anything. It means that only integral data type has to be used. You can go to the previous video where I have discussed about data type. You can see what is integral data type. Integral data type are the data type which stores whole number. Two integral data type are there, which is integer and character. So inside a switch only you can pass an integer value or a character value. So integral data type can be only used. So I'm passing integral data type called a day, and I'm opening a block, open curly braces, close curly braces, inside which I'm going to give case 1, which means that if the day is equal to 1, if the day is equal to 1, so when the variable has to be either integer or character, this case also will be either integer or character only. So case 1, what I will be doing is I will print that it is Monday. I'll just print that it is Monday. Okay, then I'll just write case 2. What is case 2? Case 2 means it is going to be Tuesday. So let me copy this and just let me change only the week. Okay, so now what I will do is just I'll change this to Tuesday. Now what I will do is I'll just copy this case and I'll just do it for some more times. Okay, so case 3, and let me give instead of case 3 I will give Wednesday, and coming to case 4, let me give Thursday. Let me give Thursday. And coming here to the 5th case, I can give, for example, Friday. Coming here to case 6, we can go with Saturday. And here coming to case 7, we can go with Sunday. Yes, this is it. So what will happen is whenever the day input is 1, it will print Monday. If it is case 2, print Tuesday. Case 3, print not only one printf can happen. Inside case 1, you can write multiple statement. So a set of instruction you can perform if the day is 1. It is not only for displaying something. You can perform some instruction here. So any number of line can be given. Okay, so write case 1, you write any number of lines you want, then case 2, any number of lines you want. But one more thing is there's something called as control statement. Control statement, break and continue, or two control statement. I will just tell you about break here. Break, what does break mean? Suppose if this case is true, and if you have done all the instruction which is written inside this case 1, you can stop. If you're not writing this break statement, break means you have to stop the process here itself. Okay, so if this break is not provided, then if the case 1 is true, then it will write like it's a pipe, like a pipe. What it will do is it fall. If case 1 is true, case 2, case 3, case 4, case 5, all the cases which is below the true case will be executed. If case 3 is a true, case 1, case 2 will not be executed, but case 3, case 4, case 5, case 6, case 7 will be executed if only case 3 is true. Suppose if case 5 is true, then 5, 6, 7 will be executed. So without giving break, what will happen? It is like a pipe. If you fall, it will go and visit all the cases which is downside to it. So this break is going to be very important part here in the switch. So I have to give break statement everywhere in each and every case. Some situation you might also not require break because you wanted to print all the cases. If you want, you can also ignore the break, but if you ignore break, what will happen? Suppose if case 3 is true, what will do? Case 3 also will be executed, case 4, case 5, case 6, case 7 also will be executed. So I'll just give the break statement in all the cases. And finally, one more thing that we can write is a default section. What is this default actually? Default means suppose if none of the case is true, then automatically this default will be done. What I can do is then default part is I can write that the input is a invalid input. Because invalid input means it is between 1 and 7 only, it is a valid input. If it is not 1 to 7, then I can say that it is invalid input. This default you can write anywhere, not only at the last. You can write in between, you can write first also, but wherever you write, first of all it will check all the case, then only the flow, the control will be given to default. Okay, fine. So now what I will do is I will just execute this program and we will check what is going to happen. So let me go here to the terminal itself. Fine. So we will just go with the execution of conditional file. 1 minute. Okay, so now I'll just go with the execution of it. Compilation is over. So now what I can give is I'll just give 2 means it is printing Tuesday, 3 Wednesday, 4 Thursday. It's printing quite well. Let me give an invalid input like 0, then it is going to the default section and it's printing. So what we will do is let me take the break section of this 3. If I take the break section of the case 3 and what is case, so what I will give is again I will compile and what I will give is I'll give 3. If 3 is given, what I told you, if break is not there, then the subsequent next case also will be executed, but you find a break here, so it will stop here. So Wednesday, Thursday, both these things will be printed. Wednesday, Thursday, both these things will be printed. So until it find once it is true, it will enter into the pipe and it will start traveling inside the pipe until it find a break. If it find a break, it will come out of the pipe, or else it will go and visit all the cases if the break is not there. Okay, I think hope you understand this now, right? So this is about switch case. We will just finish we'll finish this switch case and we will move next to one more thing. We are going to find whether a given year is a leap year or not by using the conditional statement. Okay, but why I'm just doing it at the last is leap year is very simple. Why you are doing it last? No, I'm going to tell you the entire story behind this leap year. We will be seeing a very big story that is behind this leap year scenes. So what I will do better is, first of all, I'll just tell you about this leap year. What I need to tell you about the leap year. There was 2 major calendars was available. One is Julian calendar. One was Julian calendar, which was made by Julius Caesar, the Greek king. You know about Julius Caesar. You could have read the story about Julius Caesar. So Julian calendar. One more calendar is Gregorian calendar, which is found by one more king called Gregorian calendar. And what I need to tell you about these 2 calendars is that Julian said that, that's a big story. Julian said that Earth will take 365.25 days. 365.25 days to complete a single rotation around the sun. That is what called as 1 year. When a Earth is revolving around the sun and it is completing one complete rotation, then it is called as 1 year. So what Julian is telling is that 365.25 days Earth takes to revolve. Okay, so with this what he is doing is that he is making a calendar, and using this calendar they are following. So because of the reason that, for example, in 4 years what will happen, in 4 years your fourth year, first year you will be having 365.25 days. So how many extra days you are having? You are having 1 day extra. 25 days extra you are having, but our calendar is only of 365 days only. So 25 minutes we are losing. See, our calendar is having only 365 days. This 0.25 days is there, right? This 0.25 days we are losing. Yes, we are losing this 0.25. So what will happen? 4 years, what will happen? First year extra 0.25. Second year extra 0.25. Third year extra 0.25. Fourth year extra 0.25. So what will happen after 4 years? It will cluster to give you 1 day, because 4 into 0.25 will give you 1. So for every 4 year, 1 extra day we are spending useless. We are not consuming it. Okay, so in order to use that extra 1 day, what we are doing is that for every 4 year we are adding 1 extra day. That is what called as leap year, which is included in February. Okay, so for every 4 year this 1 day is going to be missed. So in order to not miss that 1 day, what we are doing, we are increasing the number of days by 1 for every 4 years. The story does not stop there. We does not say that we does not say that leap year is only for every 4 years. No, the condition is very different. We will see the further story also. So what happened is that this is what the system that everybody was following all over the world until a certain period. But suddenly what happened is Gregorian said that he said a different thing. It is not 365 days 0.25, it is 365.242190,949 days will be taken. So he was very accurate. He is not approximately taking it as 0.25, he is taking exactly as the decimal point, 242190949 days. You might wonder what is the difference. Yeah, there is a great difference here. So if you see this, what is the difference between this Julian calendar and Gregorian calendar is that in Julian we were using some extra days. See here, we were using some extra days. How we are using extra days? We are using ANS is equal to the difference between the Gregorian calendar and Julian calendar. When you subtract this 365.25 from if you subtract 365.24, this long number, from 365.25, then you will get 0.0070905059. It's a very long number. This much day, what you're doing is you are using extra. So what you should do, you should not use any extra days. You have to reduce the number of days you are going to work, you are going to use. For that reason, what happened is actually, see, this Julian calendar was started from 325 AD, unknown domini. Okay, it was started, followed by the entire world from 325 unknown domini year to 1752 unknown domini. So how much year they were using it? Subtract both these years. So when you subtract both these things, you will get 1427. So for 1427 years they were using this Julian calendar, by which what they have done is in 1 year, if you see 1 year, you are utilizing this much extra day. So in 1427 days, how many extra days you will be using? Multiply that. Okay, 0.00780905 and 059. So when I multiply this, you get approximately 11. It means that in all these years, in all these 1427 years, 11 days was extra. They have consumed it extra. Since they have consumed 11 days extra, what they have planned is, suddenly what the world planned is that if this keeps on going, then the later period of the world, there will be a big problem in the calendar. So in order to stop the problem which is followed by the Julian calendar, what they did is, actually this problem was happening exactly at September 2, 1752 only this problem was raised. In 1752 only this problem was raised. September 2 is actually Wednesday. So what they did is, actually from September 3 to September 13, totally 11 days. From September 3 to September 13, what they did is, they asked the entire world people to lock down inside their home itself, because they wanted to know history to occur in these 11 days, because this 11 days should not be there in the history itself. So what they does is, they removed 11 days from the calendar, from the month called September, in the year 1752. In the year 1752, in the September month, what they did, they removed 11 days from the month in order to make it compensate. So 11 days extra I used, those extra used 11 days have been removed from the calendar from September 3 to September 30. Yes, fine. So now if you see here, Okay, fine. So now one more thing that I need to convey is that we said that a single rotation, Earth will take 365.24287. I'll just take it like this, okay, 24, or we will just take it extra 24, not it is not 387, it is 24 219, okay, 24219. Okay, you can see here in the Gregorian calendar, this is now the new refined day. So if you see, I told you that you missed some time, right? Because you calculated leap year by using 365 by 0.25 days, but now you are having only 365.24219 days only. So now what you have to do, leap year system also you have to change. So Gregorian, what he did is he's also changing the leap year system also. How? So what happened is, I told you that this much extra day you consume in every day. So this much extra day means it is actually equal to, every year you will be consuming 5 hours. Every year you will be consuming 5 hours, 48 minutes and 46 seconds. This much hours. What we are doing is that we are using it extra. We are using it extra. So in order to reduce this, what we are doing is that we are taking 4 years. For 4 years only we have a leap year, right? For 4 years, what happens is 4 years, uh, 48 minutes. First year we will have extra 5 hours, 48 minutes, 46 seconds. The next year also we will have the same extra 5 hours, and the next year, third year also I will have the same thing. Fourth year also I will have the same thing. After 4 years, if you see the total hours, it is equal to 23 hours and 15 minutes and 4 seconds actually. So they are leaving this 4 seconds and they are taking it as 23 hours 15 minutes. So this is not equal to 24 hours, so it is not equal to 1 day. What we are happening is 45 minute shortage. 45 minute shortage is happening. So when 45 minute shortage is happening, what to do now? So if you see here, see, for every 4 years, one leap year was the previous system. So what they did is they took 100 years, and in 100 years, if you see, for every 4 years, one leap year. So you can say that totally 25 leap years will be there. 25 leap years will be there, and if you see the 100 year, totally 75 normal years will be there. So 25 leap years and 75 normal years will be there. So if you take this 25 leap year and you have that extra 45 minutes, right, lagging 45 minutes. So what you do is you can just multiply 45 multiplied by 24. I will do 24. I will do, I'm not doing 25, but I'm doing 24. If I do multiply it by 24, I will get 18 hours. 18 hours. The remaining 6 hours we will handle it later, but now we are having 18 hours extra. So if 18 hours is taken, so what you have to do is, one day I'm going to cut. What one day? The 25th leap year is there, right? For every 100 years, the 25th leap year, I will just remove and I will make it 24 leap year. So what will happen? Every 100th year will not be a leap year hereafter. So that is the reason why 1900 is not a leap year, because it is divisible by 100, because for every 100 year there will be no leap year at all. So 1900, 2000 and 2100, they are all not leap years. So the reason is, extra 45 minutes we have taken, right? That extra 45 minutes will become 18 hours by the 24th leap year of 100 years. So the 25th leap year, which means that 100th century, what we have, the 100th century means 900th century, 2000 century, 2100 century, 2200. All these things we consider it is not a leap year. We are removing from the leap year. So now, okay, fine. So 18 hours have been handled. Fine. Now, what is the remaining hours? 6 hours. So if you take 6 hours, what will happen? For every 100 years, you have an extra 6 hours. For every 100 years, sorry, your 6 hours is missing. For every 100 years you're missing a 6 hour. So that what will happen is, first year 6 hours, second year 6 hour, third 100 year. See, first 100 6 hours, second 100 6 hour, third 100, and fourth 100. So when 400 years, for every 400 years you will have, for every 400 years you will have 24 hours. You will be taking 24 hours extra for every 400 years. So what we can do, 24 hours is missing. When this 24 hours is missing, we have to use it. How we can use it? For every 400 years you include one more leap year. So what I can say is that if a year is divisible by 4, you cannot directly say it is a leap year, because sometimes it might be also divisible by 100. If it is divisible by 100, we told that it is not a leap year, because only 24 leap year we are taking. 25th leap year we are removing. So year has to be divisible by 400 is one condition, and year, the same year, which is divisible by 4, should not be divisible by 100. So it should not be divisible by 100. So year should be divisible by 4, and year should be not divisible by 100, or otherwise. Either these two conditions have to be true, or a solo condition, which is either the year divisible by 400, because for every 400 years 24 hours is missing. That 24 hours I will just use a one extra day as a leap year. So for every 400 years I will get one leap year. So this is a big story behind the leap year. So now, using all this story, what we will write is, we will write a condition, we will write a program to find the leap year. We will find the, so first of all we will take a variable called year, and we will just receive it from the user. So scan of %d comma ampersand year. And now what I will do is, if year mod, okay, if year mod 4 equal to 0, so it is divisible by 4. And one more condition is year mod 100 not equal to 0. So these are two conditions. You have to make a compound conditional statement. So you have to join this two condition by using a logical operator. What's a logical operator? Both these things have to be true. It has to be also divisible by 4. At the same time, it should be also not divisible by 100. Okay, so when this condition is true, one more option is given, or either these two conditions has to be true, or otherwise the year should be divisible by directly 400. Why I'm checking it 400? Because if it is 400, definitely it will be divisible by 4. Okay, so I'm checking whether it is divisible by 400 or not. If this condition, any one condition, either this complete compound conditional statement or this condition, either one is true, then I can say that it is definitely a leap year. So this is a leap year. Suppose if this condition is not true, then I can say that it is definitely I can say that it is not a leap year, not a leap year. But so we'll just check whether it is working properly or not. I'll just compile it, and then now I'll just execute it. For example, I'll give 1900, which we know that it is not a leap year. Okay, it is not a leap year, but it is telling me that it is a leap year. So what you can say, actually, you have to say it is not R, because it is not R, I think so, because when this is false, okay, this is a leap year it is showing. Why this is showing as a leap year? Can you just justify this? Fine. So if you see here, it is divisible by 4. Yes, it is divisible by 4, but it is not divisible by 0. So I think this condition will give you a false. Am I right? Because this is divisible by 100. So when this is divisible by 100, this will give you false. So when this is false and this is true, the entire part will give you false. And R, this year is not divisible by 400. This is divisible not by 400. So this is also, so when both are false, then I have to go for the else part, right? So how if part is working, we have to verify. Is there any mistake that we are doing here? Is there any mistake? So if you see here, we have not given equal to equal to, we have not given any relational operator here. That was a problem here. Okay, so here mod 400, we have to give that it is equal to 0, mean divisible, right? So when we give this, and we will again try that same compilation, and then we will see, we will check by executing it. No, it's not expression. I have just compiled a different file. It is conditional, and I'll just execute hello, and I'll just give 1900 again. That's a not really leap year. Yes, that was one mistake, that we have not given this equal to conditional. That was a mistake. That is why the wrong output was given. So 1900. So if I give to go to 2000, 2000 is a leap year. 2000 is a leap year because it is divisible by 400. So it is a leap year. So I think, hope you understand the story, everything and all. Okay, so this missing time only, what they are doing for every 4 year also, they are doing 100th year, they are reducing it, they are not taking it as a leap year, and 400th year they are taking it a leap year. So for every 4 year you get, at the same time every 100th year you don't have a leap year, and at the same time for every 400 year also you have a leap year. Okay, fine. So this is it for the session, and in the next session what we will do is we'll start with looping, and we will see number crunching and a lot of many problems related to basic problems related to looping also we will see in the next lecture. Okay, so before I conclude this session, I just want to show you the MySlate.6phrase.com portal, and we have many courses available here. So if you want to take any course, you can just purchase this, and you can practice this problem sets actually. So we have several courses, and these courses are well organized courses. So I'll recommend you to purchase any of your if you are having learning plan, either C you have to learn data structure, or Java or Python, or for any specific company you want to prepare. So respective courses you just purchase, and you can just go ahead with the practice. Okay, so thank you, and this is it for the session.